So this is Precalculus, section 6.4, and we have a couple more definitions, but these are really kind of the beginning of the rest of the chapter. This is going to stick with us for quite a while. So first of all, we have what we're calling the reference angle. Okay, so if you have a particular angle that you measure out, whether it's 100 degrees or 50 degrees or whatever, then there's also a reference angle that's always associated with that. So the reference angle is the angle between the terminal side. It's the angle between the terminal side and the closest x-axis. Closest x-axis. And it's pretty significant to notice that it's the closest x-axis, because a lot of times people want to go to the closest axis, just any axis, but it's always the closest x-axis. So for example, look down here at number 1. It says find the reference angle and the reference triangle, which we'll come to in a minute, for each of the following. And for now, we're going to do them in degrees. So if I have a 120 degree angle, so here's my 120. And so notice these little lines here. A lot of times whenever we draw angles in trig, you'll see these kind of lines here. It's to help you identify some of the common angles. So it's like if this is your 0, and you know up here is 90, then notice this one right here in the middle, that's exactly halfway, so that's 45. And the other common numbers that you're going to see coming up a lot is, notice this line right here it's not halfway between 0 and 45, it's actually closer to 45. So this is kind of like a 30, and this is a 60, just to kind of give you some reference. So those lines that are already measured out, those are at some key numbers. So that's just something to kind of help you think this through. So a 120, it's going to be past the 90, and then it's going to be all the way over to here. So this is a 120 degree angle. Notice I drew in that angle, that arrow to show the rotation. All right, so the reference angle, if we go by what we said a minute ago, the reference angle is the angle between the terminal side and the closest x-axis. Well, the closest x-axis is right down here. So it's that angle between that terminal side and the closest x-axis. Well, think about it. If over here was 120, and you know all the way over to this end of the second quadrant is 180, then the reference angle right here is 60 degrees. So the reference angle for a 120 is only 60 degrees. Okay, look at number 2. If I have a 210, so here's where I start. So 210 means I'm going past the 180, and 210 would go all the way to here, because wouldn't it be like 30 past the 180? So here is my 210. Okay, that's a 210 degree angle. So the reference angle is between the terminal side, so that side we ended on, and this time isn't the closest x-axis this direction, so it doesn't matter which direction. And right now we're not talking about direction, so I don't care that it's going the other direction, but it's just an angle measure. So a reference angle is not positive or negative. Maybe we should put that up here. Not positive or negative. So reference angle is not about direction, it's only about a certain angle measure. So in this case, since all the way over here to this line was 180, and then in order to get to 210, didn't we go an extra 30? So the reference angle is 30. So let's put here reference angle 30. Over here, the reference angle was 60. Okay, let's look down here at the 360. So if I have a 360, so I start here, so wouldn't 360 be one full circle? So this is a 360. Okay, here's one that's kind of strange, right? So that means the terminal side is right here on top of the initial side. Well, the closest x-axis is the one that it's laying on. So do you see that there is no reference angle? So we would say that the reference angle is 0 degrees. Okay, what if I have an 80-degree angle? So here's my initial side. If I rotate to 80 degrees, it's going to be just a little bit short of, so this is my 80, of the 90 degree, right? So again, you're going to the closest x-axis. So this time, the closest x-axis is over here. So in this case, the reference angle is still 80 degrees. Now, something to keep in mind, since you're always going to the closest x-axis, that means your reference angle is always going to be less than or equal to 90, right? Because if you're in the second quadrant, the closest x-axis would be over there on the left side, but it's going to be less than 90. Okay, so that's just something to kind of keep in mind. All right, so that's the idea of reference angle. Let's talk about reference triangle. Okay, so a reference triangle is going to be a right triangle. Let's see, what color do I want to do this in? So a reference triangle is going to be a right triangle between the terminal side. It's okay if I just say TS, between the terminal side and closest x-axis. So it's very much related to a reference angle. So if you look at number 1, we've got a 120 degree angle. I know the reference angle is 60. So the reference triangle is going to be the right triangle between the terminal side. So here's my terminal side, and then the closest x-axis. Well, if I were to draw a line straight down to the x-axis, straight down, so that means this is perpendicular. So do you see that this right triangle formed here? That is your reference triangle. So the reference angle is always going to be inside the reference triangle. And maybe we should make a note. Let's put here containing the reference angle. Okay, so that's just a definition. So that triangle that forms around your reference angle is called the reference triangle, and it's always going to be a right triangle because you're always dropping a perpendicular line to the x-axis. So on number 2, here's my terminal side. Remember, my reference angle was the one right up here. So if I were to draw a line straight up to the x-axis so that it forms a right angle, so that is my reference triangle. Notice it's got the reference angle on the inside. Let's come back to number 3 in just a minute. So on number 4, here's my terminal side. If I were to drop a perpendicular line straight down to the x-axis, so here's the right triangle that is formed. It's got that 80-degree angle on the inside of it. Now, because on number 3, because my reference angle was 0 degrees, it's kind of like you don't really see the reference triangle. So it's like, here's my terminal side, and it's on top of my initial side, and it's like, here's my perpendicular. So it's kind of like if I were to kind of cheat a little bit, even though I know that's really not a 0 degree, it's maybe a 10 degree or something. It's kind of like that triangle doesn't really exist because the terminal side is on top of the initial side. So it's kind of, let's put it this way. Yeah, there's a reference triangle, but we're going to put it in quotes because really the reference triangle is just a line because one side is on top of the other side. So don't get hung up on that. It's just vocabulary. Okay, so can we talk about reference angle and reference triangle if we're talking about radians? Of course, but if you start in radians, you stay in radians. So let's first of all find the reference angle. Okay, so if I have a 2/3, so here's my initial side. So 2/3 is going to be between it's going to be between the pi over 2, half of pi, and pi. So 2/3 is between 1/2 and 1. And if you kind of think about it, wouldn't each of these lines right here be thirds, right? Because here you have 3, and another 3 is 6. So 6, I'm sorry, not thirds, but there would be sixths, right? Because it's kind of like this is a 1/6, and another 1/6 would be a third, and another 1/6 would be 3/6. So again, it's not that big a deal to recognize that, but it might help you draw them more accurately. Not that I care that much about accuracy, but so 2/3 is going to land right here. So here's 2 pi over 3. But okay, you got to have some critical thinking. You got to have some logical thinking for fractions. If that's 2/3 and this is 1 pi, then the reference angle right in here would be 1/3 of pi, right? So the reference angle is pi over 3. And if I were going to turn this into a reference triangle, I would say, okay, here's my terminal side. If I were to drop a line straight down so that it's perpendicular, here's the triangle that's formed, and the reference angle inside there is pi over 3. Okay, so look at number 2. If I have a 5/4, so here's where I start. And something to keep in mind, remember back on, I don't remember, 6.2 or 3, whatever section it was. Remember how we said if this is pi over 2, that we said halfway between those are the fourths. So think about it. If I have 5/4, each quadrant has 2/4, right? So from here to here is a fourth. Here's another fourth, so 1/4, 2/4. Here's 3/4. Here's 4/4. So then 5/4 is going to land right in there. Do you see that? Just to give us some accuracy, it's going to be halfway between the pi and the 3 pi over 2. So here's my 5 pi over 4. And if I were going to think about the reference triangle, I'm going to go from that terminal side straight up to form a right angle. So that's my reference triangle. And remember how we said the reference angle is always this angle that's right inside here. Well, if this was 1 pi and I went an extra 1/4, isn't the reference angle pi over 4? So let's put here reference angle pi over 4, and on this one the reference angle was pi over 3. All right, I'm about to make this super easy for you. Here's what I want you to notice. Okay, make sure you catch this because you're going to use it forever. Notice on the first one, notice on number 1, the original angle was 2 pi over 3, and the reference angle was pi over 3. So the reference angle was just this part. Is that always going to be true? Do I really have to look at the picture to know what the reference angle is? Notice on number 2, the original was 5 pi over 4. The reference angle was just pi over 4. So the reference angle was just this part. That's always going to be true. You don't have to do the math. You don't have to reason it out. The reference angle is always just going to be pi over whatever your denominator is. So we'll come back to number 3 in a minute. Let's go to number 4. First of all, if I want to know the reference angle, I can tell you right now that the reference angle is just pi over 6. Now, in order to draw the reference triangle, I still have to measure this out, but that was nice to just be able to pull that out. So let's draw it out just so we can kind of picture the reference triangle. So here is my initial side. 11 pi over 6 is going to be 1 and 5/6. So I'm going to go all the way around to here, past 1 1/2, but not quite to 2, right? So that's my 11 pi over 6 angle. And if I want to picture the reference triangle, so here's my terminal side, if I drop that line, that perpendicular line, straight up to the x-axis, then here's my reference triangle, and this angle inside here is the reference angle, that is the pi over 6. All right, so on number 3, let's draw the picture. If I have pi, an angle of pi, so here's 0, pi would be all the way over here, so the terminal side is right there, so that's an angle of pi. So in this case, what is the reference angle? Well, if the terminal side is on the axis, then the closest x-axis is the one that it's laying on top of. So this is one of those where it's kind of like there's not really a reference angle or a reference triangle, because the reference angle, well, what's the distance between the terminal side and the closest x-axis? Well, if it's laying on top of the closest x-axis, then the reference angle is 0. Okay? So that was section 6.4, or at least the beginning of section 6.4. And we'll do a separate video for 6.4b, the second half of 6.4.